In problem 39, we have a six-sided number cube, and that's just another name for a die. And it's weighted so that the probabilities of throwing 2, 3, 4, 5, or 6 are equal, and the probability of throwing a 1 is twice the probability of throwing a 2. So normally in a die, you have each side having equal probability. And so each side has a the probability of landing on each side would be 1/6 in a normal die. Kind of like what I have over to the top, to the right and on the top there. So for each value of the die, the probability would be 1/6. Well, in this case, we have something slightly different. 2, 3, 4, 5, and 6 are all the same, but 1 is twice the value of 2, or it's twice the value of any of the other ones. So you can't use 6 here. If 2, 3, 4, 5, 6 were all 1/6, and then the probability of 1 would have to be twice that. You'd have 2 6 plus 1 6 1 6 1 6 1 6 1 6. You would have 7/6. So for this die, we're going to have something slightly different. Well, the numerator of the 1 would have to be 2, and all the other numerators 1, showing that it's double. And the denominator then would have to be the sum of all of those, so that would be 7. And so our probabilities are now 2/7 and then 1/7 for the other 5. When you add them up, it gives you a total of 1. So the sum of all the possible outcomes, the sum of the probabilities of all the possible outcomes, has to equal 1. Alright, that's just getting it set up. Now the whole problem says this: if the number cube is thrown twice, what's the probability that the sum of the numbers thrown will be 4? Well, for this we have to look at all the different ways that we could come up with a sum of 4. And we could get a 1 on the first roll, and a 3 on the second roll, a 2 on the first roll, a 2 on the second roll, a 3 on the first roll, and a 1 on the second roll. And when we have these complex events, we need to get a 1 on the first roll and a 3 on the second roll in order for the first sequence to happen. Then we're going to use the multiplication rule of probabilities. And so that would be the probability of getting a 1 times the probability of getting a 3. So you have a 2 in 49 chance of rolling a 1 and then a 3. Of rolling a 2 and a 2 would be the probability of rolling a 2 times the probability of rolling a 2, which is 1/7 times 1/7, or 1/49. Then a 3 and a 1 would be the probability of rolling a 3 times the probability of rolling a 1, which is 1/7 times 2/7, or 2/49 again. And these should be the only possible ways that we can get a sum of 4 in 2 rolls of a die. So we've computed the individual probabilities of each event: a 1 and then a 3, a 2 and then a 2, a 3 and then a 1. And now we're going to have to add those together and use the addition rule of probabilities, which would say what's the probability of getting a 1 and a 3, or getting a 2 and a 2, or getting a 3 and a 1. And that would be 5/49. And so our answer is B. So this problem particularly emphasizes the multiplication rule of probabilities and the addition rule of probabilities, and putting the two of those together to find the probability of some complex events.